In this tutorial, you'll learn how large language models work and how to apply them to real-world NLP tasks like text classification, sentiment analysis, translations, and even building your own chatbot. Through hands-on coding and prompt engineering, you'll gain essential skills that are highly valued in today's job market. You'll not only learn how to integrate OpenAI's GPT models into your code, but also how to work with open-source LLMs using the HuggingFace library. We'll specifically use Meta's LLaMA model, and the tutorial gives you the freedom to choose between OpenAI or HuggingFace models to follow along. The tutorial is 100% free, beginner-friendly, and designed to help you apply these powerful models to real-world NLP tasks. We'll start by exploring what LLMs are and their key components like temperature and embeddings that help you understand LLMs and utilize them fully. Next, you'll gain hands-on experience connecting to OpenAI's GPT models and HuggingFace models, experimenting with them through code. We'll cover essential prompt engineering techniques like writing clear prompts and using chain of thought. Finally, we'll apply everything to real-world NLP tasks, including text classification, clustering with embeddings, topic modeling, NER, and even building your own chatbot. Adding this expertise to your CV will make you more competitive in the job market, as companies are increasingly seeking professionals with experience in LLMs. Whether you're aiming for a role in AI, data science, or software development, this tutorial will equip you with in-demand LLM skills that can boost your career. A large language model is a mathematical function that predicts what word comes next in any piece of text. For example, if I provide the input, I am going to the model might predict supermarket as a potential next word. LLMs can also generate full sentences by iteratively appending each predicted word to the input and then predicting the next word again. This process continues until the model determines that the sentence is complete or reaches a specified length. For example, if I provide the input, "What's the capital of France?" the model will predict the answer one word at a time. The first word it predicts is "the," which is then appended to the input. Using the updated input, the model predicts the next word, "capital," and appends it to the input as well. This process repeats with each predicted word being added to the input until the model completes the answer or reaches its maximum allowed length. In this case, the final answer is "the capital of France is Paris." All the words that the model can generate or read are a part of its vocabulary. A vocabulary is a collection of words built from all the text that the model learned from. But human language often involves words that can have many variations, like adding suffixes, prefixes, or changing tenses. This can result in a large number of very similar entries in the vocabulary, since each variation of the word might be treated as a separate entry. For example, break, breakable, and unbreakable could all end up as individual words in the vocabulary, even though they have common parts. As humans, we can understand the word unbreakable even if we didn't see it before. We can break it down into smaller parts, un, break, and able, and from here we understand the word. Now, LLMs pre-process text in a similar way through a process called tokenization. Tokenization splits sentences into words or subwords called tokens. Each token is assigned a unique ID or number, and this information is stored in the model's vocabulary. The vocabulary is created from all the text the model will learn from. This means the words and subwords in the vocabulary came directly from the training dataset. The training dataset is usually billions of text samples from the internet, like books, articles, posts, and more. Preparing this vocabulary is an important first step before the model can start learning how to generate and understand language. The model's learning process is called training. During training, the model goes through each text sample in the dataset, randomly masking or hiding one or more words. The incomplete sentence is then given to the LLM, which is tasked with guessing the missing words. Initially, the model might make random guesses, but over time, it improves through a process called backpropagation. Backpropagation is the process a model uses to improve its predictions over time. It starts by checking how wrong the model's guess was. This is called error. Once the error is calculated, the model adjusts its parameters slightly to reduce this error and make better predictions. As mentioned earlier, a model is essentially a large mathematical function that takes input and produces output. The adjustable parts of this function are known as parameters or weights. They determine how the model processes information and produces output. We'll circle back to them later on. Trying to predict missing words or next words in a sentence is called causal language modeling. It enables LLMs to understand and generate text, but it might often lack the ability to respond accurately to specific tasks and questions or follow detailed instructions out of the box. In this example, instead of responding to the question, the model generated a list of similar questions as its output. The training dataset might have had groups of questions like that, so it's generating a similar structure. To help the model respond to input questions and tasks, we use a process called instruction tuning. This step comes after the causal language modeling and builds on top of the trained model. Just like the previous training, we are trying to also predict missing or next words in the text, but this time the dataset is more specific, containing only examples of questions or tasks and their answers. This dataset is more focused, often containing fewer samples than the general LLM training dataset. While it's sufficient for teaching the model how to respond to tasks or questions, it doesn't provide enough language data for the model to learn general language patterns. That's why causal language training is done first and instruction tuning follows to refine the model's ability to handle tasks effectively. Let's take a step back and dive into how the model learns. Let's use a very simple example to understand this. Imagine we're training a model to classify animals as either dogs or cats based on their height. As we mentioned earlier, a model is a mathematical function, and in this example, we'll use a simple equation y equals mx plus b. This line helps the model decide. Anything above the line is a dog, and anything below the line is a cat. In this example, the model has two key adjustable parts called parameters or weights, which are m and b. These parameters control how the line is drawn. For instance, if we set m equal 1 and b equal 1, the model will draw this line. However, at the beginning, the model doesn't know the best values for its weights, so it starts with random guesses. The model then calculates this error by checking how many animals were classified incorrectly. These mistakes are shown in red. Now the model can adjust m and b slightly to make fewer mistakes using a branch of mathematics called calculus. The model repeats this cycle over and over, improving a little bit each time. By gradually tweaking the parameters, it learns from its mistakes. Eventually, it becomes good at separating dogs and cats based on height. This step-by-step improvement is how the model learns or trains. As the model learns, it adjusts its parameters to better classify the data. In our simple example, there were only two parameters, m and b, which meant that the model could only draw a straight line to separate dogs and cats. But real-world problems are far more complex, and a simple line isn't enough. The more parameters or weights a model has, the more flexible and intelligent it becomes, allowing it to capture intricate patterns in the data and making smarter predictions. More weights mean better accuracy, but it also means that it will be slower to process and will require more computational resources and cost to run. So it's a trade-off between cost and speed versus accuracy. To handle even more complex tasks, models organize these parameters into layers. This is how the previous equation can be represented in a layer diagram. It has one input layer and one output layer, but the bigger models has more layers in between called hidden layers. Each layer processes the data in different ways, with the output of one layer becoming the input for the next, allowing the model to capture increasingly intricate patterns. Now that the LLM is trained, it's time to generate some text. Just as explained before, the LLM generates one token at a time. It does this by calculating the probability of each word in its vocabulary. We can then choose the word or token with the highest probability, but sometimes choosing the less likely word makes the response feel more natural or creative. The frequency of picking these less likely words is controlled by a setting called temperature. When the temperature is set to 0, the model will always pick the most likely word, giving you very predictable and consistent answers. If you ask the same question multiple times, the answers won't change. As the temperature gets closer to 1, the model becomes more creative, occasionally picking less likely words. This can make the text feel more interesting and unique. The higher the temperature, the more likely the model chooses less likely words. The last concept we are going to be covering today is called embeddings. Now, as we discussed before, the LLM is just a mathematical model and it understands text in numerical form. It converts each word from its vocabulary from the assigned ID to a whole vector of numbers describing the word. Basically, the output of the last hidden layer is the embeddings. Each number in the array internally represents a feature, and the number indicates how much this word is representing the feature. In this example, the man, woman, king, and queen score high in the human feature, but only the king and queen score high in the royalty feature. What's awesome about embeddings is that you can see how close or far two words are semantically just by getting the difference between the two arrays of numbers. And you can play around with the numbers to get all sorts of insights. For example, you might see the difference between the man and the woman is the same difference between the king and queen. And difference between the man and king is the same difference between the woman and the queen. Now, LLMs also embed full documents so we can efficiently get the closest document to whatever input text we desire. This can help us look up documents efficiently. We can also cluster similar documents together into groups. We now understand a lot about LLMs and how they learn and produce text. Now let's switch gears and see how we can utilize those LLMs in our code, unleashing the power of text processing and generation in our applications. So let's start our tutorial. We'll start by getting our OpenAI token that will help us call ChatGPT through our code. So let's go to Google and search platform OpenAI. And this is a website that is going to help you get the API keys to call ChatGPT from your code. You can also go to platform.openai.com and make sure to log in. If you haven't done so already, you can just go to openai.com and create an account. It's free. It might ask you for your phone number, but that's fine. Then you can go to API references at the top right. Then underneath authentication, you can find a link to API keys. So just click it and it will get you to the screen. Now you can also go to this link directly if you are currently logged into OpenAI, which is platform.openai.com/settings/organization/API keys. To generate the API key, all you need to do is press create new secret key. Now you can call this secret key whatever you want. I am going to call it LLM tutorial. You have the API key presented to you, so just copy it and save it somewhere because we'll be utilizing it very soon. OpenAI gives you $5 worth of credit for free when you create the account. So this is way more than enough to go through this tutorial. It will only cost less than $1 to do. But again, it's free because OpenAI is giving you $5 for free. And if you prefer to not use OpenAI and only use HuggingFace, then you can do so. I will give you the option in the tutorial later on, and I will build the same functions with OpenAI and HuggingFace. But OpenAI is good to add to your CV. So if you can take those $5 of free credit from OpenAI just by signing up, then I would encourage you to follow along with me. One of the easiest ways to run Python is to use Google Colab. It's just a Python notebook that you can run online. So you can just search Google Colab on your Google and just click on this and press new notebook. This will get you to a Python notebook that you can run. So right there, you can just name it whatever you want. So we can name it here LLM intro. And right there, those are called cells, and you can write code inside of them, like print hello world, and you can run it by like pressing Shift Enter, like this. So this is hello world. You can also have text cells. So you can just write here, for example, installing requirements, and then we can maybe set up the OpenAI API, which calls ChatGPT. load OpenAI chat GPT. So Collab also gives you the ability to run on GPU. So you can just press runtime, change runtime, and you can press on T4 GPU, right there. And this will give you a GPU machine that you can run your models on. Now, OpenAI doesn't necessarily require it to have a GPU because it runs on the GPU on the OpenAI side, but we'll be using an open-sourced LLM that will need to have like GPU power to run. So in installing the requirements for OpenAI, we can just pip install OpenAI like that, and it will install OpenAI. Now, Collab has a lot of other libraries as well. It might have also OpenAI, that's why it finished fast. But you can have like transformers. It has pip install transformers, which is the HuggingFace library that has all the open source models that we can use. And it has a lot of other libraries. So if you're running this locally and you don't find the library, you can just pip install it like so, and I can tell you how to get it from Google. You can just go to Google, pip install OpenAI like that. Just write it like in any random form, and you can just get the exact command and just paste it right there, while preceding it with an exclamation mark. And this is how you run terminal commands in a notebook. So right here, when loading the chat GPT, you can run from OpenAI import OpenAI like that. And from here, you can just run OpenAI client equal OpenAI. Then you can open the bracket, and we need to give it the API key that we copied like a minute ago. So just paste it right in, and yeah, you will need to get your own API key right here because this one will be deactivated after this tutorial. So right now, we just need to send a normal message to ChatGPT. We can just ask it what's the capital of France, and it just responds back. So to send messages to ChatGPT, we can just have an array of messages. And this array of messages will have a dictionary that have two things: a role, and which tells it who is saying this. I am the user that is saying this. So we either have user, or we either have user, we have assistant, which is going to be the model response, and we have called a system. I will go over the system prompts later on, but right now the user is me, and the assistant is the response that is coming from the model itself. The second parameter is content, which is going to be the question that I'm asking or the query that I'm asking. So you can write what's the capital of France like that, and then to call OpenAI you can just have OpenAI client like this .chat, then completions, then create, and then give it the list of messages, and also tell it what model to use. And you can give it here the GPT 4040 mini like that, and you can run it, wait for it to respond. It responded already, so you can display the output, and you can see here that we have a lot of output that is chat completion, you have the choices, you have whatever, and you also have a lot of metadata right there, but the output, the actual output of the model is right there. The capital of France is Paris, and you can get this by just like filtering the output. So you can have output dot choice of 0 dot messages message dot content. This is choices, not choice. So you can just run it again. The capital of France is Paris. You can see that it's responding quite good. Now, while we're producing data, let's also cover temperature. So temperature, as you remember, is the amount of randomness that the model is able to produce, and by picking less likely words. So the temperature, you can just copy paste the way that we can call the model from, and you can just copy paste this filtering, and yeah, this is it. So right now we can just call the temperature to be 0 so that we can make a discrete output that doesn't change. And you can here tell it to give me 3 names for a new AI assistant, and this will produce 3 different names, so Astra, Navi, and Echo. And then you can just run it again, see if it changes or not. So it didn't change. So let's now change the temperature to a higher number. Let's call make it 0.7. See how the output is going to be. Now we are getting different names. So instead of Asra, Navi, and Echo, we are getting Ava, Nexa, and Echo. And then a little bit of randomness right there. And then if we called it again, like this. So right there, it's Astra, Navi, and Lumos, which we didn't receive Lumos before. So you can see that the level of randomness is actually working. Now, before we proceed to HuggingFace and using the open source LLM, let's wrap this up by having a function that takes in a message and produces the output, just a convenience function, so that we can use it instead of the HuggingFace, or we can use the HuggingFace instead of it. And yeah, so right now, right there, we can write OpenAI response function, and in here we can have get response like this from OpenAI, and this takes in the OpenAI client. It also takes in the prompt, and it takes in the temperature like that. Let me copy paste it, and the temperature would be 0 by default. And then we can have the messages is equal to the messages. And then we can call the OpenAI client chat completions, create, give it the GPT-4 mini, give it the temperature, and return back the output. Now, this is just a convenience function that is going to help us maybe call the model a little bit easier. So you can have a prompt like this that says, write me 3 bullet points as to why I should learn LLMs as a software engineer, like that. And instead of just doing all this code again, we can just call a function, a convenience function, give it the OpenAI client like this, and give it the prompt, and we should have the output at the end, and we can print it out easily like that. I think I misspelled this, so it's OpenAI client, so you can just run it. Now, you can see the output as enhanced problem solving, career achievement and market demand, and interdisciplinary applications. Now, this is wonderful, and it's working good, and everything that we will do in OpenAI, we can also do with an open source model. And in the next section, we'll understand how to load a HuggingFace model into the GPU, since our GPU is already running, so we can just work on top of that. And then we'll use prompt engineering techniques that will work for both OpenAI and HuggingFace. So if you don't want to use OpenAI for its costs or anything else, feel free to use HuggingFace, as both are interchangeable and both are LLMs that we are learning how to prompt engineer. Now you can go to HuggingFace right there. So HuggingFace is a library that has a lot of models and a lot of LLMs to choose from. It has a lot of open source LLMs, but the one that we are going to use is called LLaMA. It's from Facebook, and you can just write LLaMA HuggingFace right there. It will open up. Maybe just use this one. And you can see that you have multiple variations. You have LLaMA 3.3, you have LLaMA 3.1, and the one that we are going to use is LLaMA 3.2, and it's going to be only 3 billion parameters. Remember, the more parameters, the more resources that we're going to use, but 3 billion is going to be fast enough for us, and it's going to be loaded very conveniently in Google Colab. So I'll stick with the 3 billion parameters and not scale up to 70 billion or something like that. So the one that I used is 3.23 billion parameters instruct. If you don't find it here, press on expand other models, and you should be able to find it right there. So you can just click on it, and first make sure to log into HuggingFace. So it's free and easy. You can just enter your email and put your details, and you should be able to find this quite easily. And you can just access this model by simply going to this URL, huggingface.co/meta LLaMA 3.2 3 billion parameters instruct tuned. So this is the model that we are going to use, and you can just copy this model name and come here and paste it in, like model name, paste it in right there. This is how HuggingFace will know which model to download. Now you can see here I'm granted access to this model because I prepared for this, but if you choose any LLaMA model or that needs to have you like agree to its terms of use, so for example this one I didn't agree on it, so you can just when you log in, you can just press agree and send request like that. It usually takes a few minutes, so you can go get a drink or something like that, and after that you can just refresh the screen and you'll be granted access. So just give it a maximum of 5 minutes and you should be granted access. Now the last thing is that because you're granted access, you'll need to identify yourself as a user. So you can go here, press on your profile, and then go to edit profile, then go to access tokens, and it will ask you to enter your password. After you enter your password, you can see your tokens. Maybe you'll find 0 tokens, but that's fine. You can go create a new token, add the token name. You can call it LLM tutorial or whatever you want. Yeah, you can just make it read or write. You can just make it write for now if you want to, and you'll press create, and then this is the token that you have. So you can just copy this, press done, and you'll find it right there. Again, this token will be removed after the tutorial, so make sure to get your own. And then the HuggingFace token is like this. You can just paste it right in, and in here we can do a new section called HuggingFace load HuggingFace LLMs. Now we want to import torch. We want to also import from transformers, import auto auto model for casual LLM, and auto model tokenizer, and the pipeline. We also want to have to log in using our token. So for that, we are going to use the HuggingFace hub, and you can just run this. And after that, you can have log in and give it the token. Make sure to have a dot and give it some time to load. Maybe it's going to take a little bit of time. So run those two and you should be logged in. So after logging in, we can start loading in the model and the tokenizer. Here we'll have to load the model and the tokenizer and then feed it in the pipeline so that we can have a full output from the LLM. So it's going to be a little bit longer while we're setting up, but afterwards it should be as simple as this function while we're calling it. So yeah, so right now we're going to load in the model like that. We are going to call auto model for casual LLM. We are going to tell that it's a pre-trained model, it's already trained, and we give it the model name that we copied from HuggingFace, and then we say that it's on CUDA, and we tell it to have an auto touch D type. We also want to load in the tokenizer, and we can use also auto tokenizer and give it the model name. And for generation purposes, when we generate multiple messages, it sometimes gives the like the warning that the padding token is not set. So please set it to end of sentence token. So that's what we're doing right here, just to not get the warning in future messages. Then we need to put in the model and the tokenizer into one pipeline so that we don't tokenize and then we run it through the model. We can just do this by having the pipeline initialized, which we loaded from transformers. We tell it that it's text generation. We say also that it is, we give it the model and we give it the tokenizer, and it initializes the pipeline for us. Then we will need to do the simple function again, but for HuggingFace. So we are going to get the response from HuggingFace, give it the pipeline, give it the prompt, give it the temperature, say the messages, and for each message, of course, there's going to be a role and the content, and there's also going to be a prompt. And right here, it's a little bit longer right there, but sampling is going to be a flag, whether like the temperature is going to be 0. This is no sampling at all. When the temperature increases on top of that, then the sampling would start to be true. This is an additional flag that we'll need to set up here, but it shouldn't be that inconvenient. Hopefully it's very straightforward. Then we can set up some arguments. Say that there's a maximum generation arguments of 2000 tokens. This is more than enough for our use cases. We are going to return full text equal false, because full text here means that it returns the question and the answer. We just want the answer to the question. We have the question. So we're going to set that to false, and we are going to set the temperature as we received in the function. And to receive the output is going to be the generated text, and this is the exact field that has the output. Just like the OpenAI one, there was choices and messages and content. Here, they're just generated text, and you can just choose it. We can also ask it something that is really simple, like what's the capital of France, and it should respond quite fast. So you can have here get response from HuggingFace like this. Ask it what's the capital of France, and it should have an output for us. So right there, the output is the capital of France is Paris. Then we are going to be doing some prompt engineering techniques. Prompt engineering helps us to get the best out of our models. It helps us do a lot of tasks with our models also, like task classification, sentiment analysis, named entity recognition, grouping text together, like extracting different things from our text, and summarizing, even building a full chatbot with a good prompt engineering technique. It also helps us to get better output from our models and better accuracy levels. And it also gives us the ability to tweak it to our very specific needs. We are going to be covering a lot of concepts. Those concepts are either going to be applied with HuggingFace. Again, this one is free and you can utilize it. You already loaded it into memory. And you also have the OpenAI option. You can use them interchangeably. So instead of using this function, use this function, and you see you have very similar inputs to that. So use whatever you want. Just remember, OpenAI costs a little bit of money, and it gives you a $5 starting budget that you can play around with. And HuggingFace is totally free. LLaMA is free to use. So those prompt engineering techniques can be applied to any LLM. So right now I'm going to use the HuggingFace for the rest of the tutorial, and yeah, feel free to continue with that. So the first concept is just writing clear instructions and dividing the inputs and the outputs and having the output in a specific format. This will be our building block for our prompts and prompt engineering that we will do later on. Before we start, a lot of the concepts that I covered here are covered in the deep learning course for this course exactly. It was a good course. It's not sponsored or anything, but this is what I learned those approaches from, and here I'm going to be summarizing it very quickly so you can get this knowledge fast. But feel free to check them out. They're very good. And this course is also free. So for here, you can just have a principle. I am going to have principle 1, which is going to be write clear and specific instructions, like that. The first thing that we are going to be using is that we are going to be separating the input from the prompt. So we are going to use delimiters to separate different parts of the prompt. So use delimiters to clearly indicate parts of the prompt. And we can use different things like XML tags. We can just use ticks. We can use dashes. We can use backticks, and we can use other things as well, whatever we want. So let's say that we have a review on our application and we want to determine whether this review is positive or negative or neutral or something in between. This is what we call sentiment analysis in natural language processing. It's a text classification problem, and it classifies text into 3 different classes. And here we'll cover also text classification with more detail, but right now we are going to be focusing on how to separate the input from the prompt itself. So the review here is going to be, this product is awesome and I like it so much. This is the review itself. The prompt itself that is going to be classifying this is going to be as follows. And we can say determine the sentiment positive, negative, or neutral of the following review, like that. So this is going to determine whether this is positive, negative, or neutral of the review that we will be injecting below. So the review here is between 3 backticks, and this is how you separate. The actual prompt itself from the input, which is the review itself. So you can have review and just close it right there. And this is going to be an F string so that we can inject review. And right there, review is between 3 backticks, and we also mentioned that it is between 3 backticks. So now it has very clear distinction between the review and the command itself. So it should be able to output whether this is what output this is going to do. The autocomplete shows the OpenAI, but I can go up there, copy this, and paste this right in. And instead of OpenAI, I can just put the pipe. And yeah, this is the output. The sentiment of the review is positive. And you can also, like, if you want to run it with OpenAI like this, you can just do it. The sentiment of the review is positive. So you see that those are some warning statements. You can ignore them, but the output is right there. This is the print output right there. And this is also the output of the OpenAI. So both of them are quite similar, but when the output is more complicated, you can see that they will differentiate. So that's the first approach, is to separate the actual like input and the prompt from each other, and this is how you can segregate different parts of the input. Later on in this tutorial, we'll use some XML tags, and you might use also dashes to segregate some parts of the input. Now, the second thing that we are going to learn is going to be asking for a structured output. Ask for a structured output. And this might be for like as in JSON, XML, or etc. Anything in between. Now, the problem right now with this output is that the sentiment of the review is positive. Now, this is understandable with humans, but actually, like systems, we want to have either true or false, or like a specific word like positive, negative, neutral, so that we can just insert it into the database. So we can just tell the LLM to output the data in a structured format so that other systems can read it and understand it, insert it into databases, or take actions upon it, and like utilize this data quite easily. So yeah, the goal of this is to like move away from this free floating text that humans can understand and go to structured output so that other systems can understand it as well. So we can just copy paste this and go down, and instead of just leaving it right that like here, we can tell it to generate the answer in a JSON format that has the following fields like this. And in this one, we have the sentiment, which is going to be equal to the, let's write it sentiment. So a JSON, this is going to generate a JSON format that has the following fields. The field that it's going to have is called sentiment, and this is a string that is one of those values, which is going to be positive, negative, or neutral, like that. And being specific here is going to be always good for the systems to understand. So we can just say if sentiment is going to be equal positive, or if sentiment is going to be equal negative in our system, and then take an action from here. So I am going to also enforce it. So always respond with a valid JSON. Do not include any extra characters, symbols, or text outside the JSON itself, because I am writing this because sometimes it tells me this is the JSON output, and then it provides the JSON. I don't want any of that, so I can just make another statement to enforce it. So yeah, this will enforce the JSON to be good. So you can just have this in different lines like that, and you can run it. You can see that the sentiment here is positive. This is a structured output that we can utilize in other systems. And you can just have like import JSON, JSON.loads the output, and we can see that this is now a dictionary, a JSON dictionary, that we can just see, for example, of sentiment, and it's not text anymore, it's just a JSON file. You can see this. So yeah, this is a dictionary or a map if you're coming from other languages than Python. So right now, the LLM is classifying text as either positive, negative, or neutral based on its common logic, which right now is working fine. But what if we have classes that are very specific to our use cases? And it's going to be hard for the LLM to understand what those classes mean and how they should function and things like that. So the best thing to do here is to use something called few-shot learning, which is to give the user, to give the LLM, the examples with their classes. So we can give it the text and its class, then a text and its class. And it will understand from here how to classify the text based on our use case. This like showing the LLM some samples is called few-shot learning. Now, the LLM here is not, actually it's few-shot learning, F. The LLM right here is not actually training, but it will copy-paste the, like try and imitate how your output is. So right here, I'm going to be also classifying a review. But we are going to be classifying it into 4 different options, whether this is going to be service, quality, ambience, or pricing. Like, what is basically this review is talking about. And like at the beginning, you might not know what those are, but as you can read the review, the lighting in the coffee shop, so basically it's in a coffee shop, it's so warm, and it makes the place feel inviting. And what I do right here is that I give it the review, and it's also in triple backticks. And then I also tell it that here's a review. A barista was incredibly friendly and made my drink quickly. So this is talking about the service. So I just gave it the output of it. I just gave another example of quality. I just gave another example for ambience. And I gave another example for pricing. The more samples that you give, the more accurate and the more understanding that it's going to be. So you can just take into consideration the amount of tokens that you are having, because there is a maximum number of tokens that you can push through to an LLM, whether this is HuggingFace or OpenAI. But usually you can have like a couple of examples right there, and it will be more than fine, and it will handle it quite good. So before running this, I also told it to generate it in a JSON format, by having one field, which is category, and the output is going to be one of those 4. And again, like having this structure, having this like examples to show it how it's going to behave is going to be better than actually explaining how to behave. So few-shot learning is a better practice than explaining how the model should behave. So yeah, you can just run it right there, and you can see that this right here, the lighting in the coffee shop, is talking about the ambience, and it had this in a JSON format. And again, this is some warnings. This is not related to the output. So you can just like copy paste the output right there, and you can see that this is only the output, and those are just some warnings while getting the output. So now that we finished the few shot learning part and how we can get structured output and structured input, this is our basic building blocks in building on top of that and actually having very important use cases that we can have from the LLMs. This brings us to the most interesting part of the tutorial, which is giving the model time to think. This principle helps the model to get better results and be more accurate in generating the data. So right now, this way helps the model to get the data right. Instead of like describing it, you're telling it what to, like you're giving it examples. This is one way to get better output, but also other ways we can specify, we can tell it to follow very specific tasks to get the output. And this usually in tasks, like in specific tasks that we want to have, this might get us very good results. And the other technique is called chain of thought, which is basically going to give the model like make the model like walk us through its thoughts and walk us through the steps that it had, so that it can have the final output. Now, both of them are techniques very important to boost the results from the LLM. So one of the things that chain of thought does is that it makes the model list the steps before it lists the answer. Again, the model generates the words, the answer word by word. So if it generates the answer at the beginning, it just sees the question beforehand. So it might generate the wrong answer. But if it sees steps before it and those steps are leading to an answer, it will push the model to generate the answer by the time it reaches it. So let's make this a little bit clearer. So we can just make a section called make the model think step by step, and this is chain of thought. So in this example, I have a mathematical function and I just want the answer in one number. So it's called I bought 2 balls with $10. One ball is more expensive than the other by $1. How much is the more expensive ball? So if you run that, it tells you 11. Now, 11 is surely the wrong answer. The right answer here is 5.5. So we can tell it to think this step by step. And just by telling this, like, think step by step before the right answer, it will drive it into the right direction. So right now, I have the same prompt, but before that, I told it, please think about this step by step, and at the end, please provide the answer. It should always provide the answer after it's thinking, so that it can change the answer based on the text but before it. So you can see here that it has some steps and it's doing some math, and then at the end it is producing the correct answer, which is 5.5, and this is totally different than the wrong answer, which is 11. So this is how you can get better output from the models by thinking step by step and using the chain of thought process. Also, let's now, this is this chain of thought. You can just copy this, paste it right here, and we can also specify the steps required to complete the task. So sometimes in very specific use cases, you have some a task to do that follows a very specific set of instructions, and it's better to not make the model like invent those instructions. It's better to give those instructions to the model so that it can follow it and produce the expected output. So for that, I am going to use a very simple problem. How many R's in strawberry? Actually, there is 1. There's 2 and there's 3. There's 3 R's in strawberry, but let's see what the model thinks. It thinks that there are 2 R's in strawberry, and it produced the wrong output here. So we can tell it to follow a very specific number of instructions, which is basically maybe separate the strawberry word into letters and then put a 1 in front of ours and 0 in front of others, and then sum the ones together, for example. So this is the instructions that I did, which is break down the words into letters. Each letter put 1 or 0, and then based on whether it's an R or not. And now the counter would count the ones, and then afterwards, like give us the answer. Again, the answer comes at the end so that it can like cheat from the previous output. So if you can look at this, it divided it into letters. Each letter is then associated with a number, 1 or 0, and it's 1 when it's R, and then it counted 3 ones, and then so that the output, there is 3 R's in strawberry, which is the correct output. Now, this is very fascinating, and the paper that actually like made chain of thought and introduces it, like reported accuracy levels jumping from I think 20% to 70-something%, which is very awesome. Now that we understand how to get better results from our LLMs, now we can get into the practical part and to use the model in different scenarios and in different NLP problems. So the first thing that we are going to cover is text summarization. And in text summarization, basically we have a long text. This is basically a very long review about a coffee shop. And what we want to do is we want to make it into one sentence so that it's going to be easier to read, and I can go through multiple reviews without having to read all that. So basically you can have also a prompt that would use XML tags right there. Like instead of using the slashes, we use XML tags this time. And we can inject the customer review. So this is the review right there from a coffee shop, and we are asking it to summarize it in one sentence. So this is text summarization, very simple indeed. And you can see right here, the review had mixed experiences, a coffee shop haven enjoying a cozy atmosphere and music, but disappointed by the slow service and overly sweet latte. So you can see here that it's way like less than the original one. But yeah, this is text summarization. Anytime you want to summarize any text, you can just use an LLM for that. Then what about if you have like comments in one language, but you want it to be translated into another language? So right now we can also ask an LLM to translate between languages. So let's have also translation. And in this translation, we are going to use the same customer review, and we are going to have a different command, which is please translate the customer review to French and provide only the translated text with the no XML tag. Now, right now I still have the same structure, which is the user review is between the XML tag called customer service, and I am injecting the customer review like this. So everything stays the same, just the end command is different. Now, this is going to be important for you if you have like multi-languages, or like, you know, like Facebook and Instagram have an option called C translation. So this is how you can replicate this feature. Again, this is the translation of it in French. And yeah, you can see that the translation now is working fine. So right now you know how to translate and you know how to summarize text. Afterwards, let's also extract named entities from the text. A named entity is basically anything that has a name, like a location, a person, a university, an organization. So it extracts those stuff. So named entities are a very good way for us to tag text and extract different like text for a specific, for example, university, for a specific person. It's a very famous NLP task, and now you can use it quite easily with LLMs. recognition. So right now you can also just, we'll be using the same review but also a different technique. So this is the same standard beginning of the prompt that we used in the two above prompts, but we can tell it what named entities to extract. We wanted to extract person names, organizations, locations, cities, countries, and etc. Please extract all named entities and their types. Use the following format, which is going to be named entity, then colon, and then the type of it, which is going to be one of those types. Now, again, this is very important in text processing and filtering and actually tagging. So if you can see in articles, this is talking about, for example, this is talking about a specific movie. This is talking about a specific actor. And the tagging here can be automatically done with named entity recognition. So you can see here that Coffee Haven is an organization, Caramel Latte is the product, almond milk is a product, coffee is a product, and you can see here that it's extracting named entity recognition with very ease. Before those models, it was actually like we needed very specified models to run and extract data and process them, but now it's very simple and you can do it here like quite easily. The next thing that we are going to learn is called topic modeling. Now, topic modeling is basically going to extract some topics from any given text, and it also extracts certain themes for each topic. Now, this is also very important for clustering text together. This is important for tagging text, putting it into specific categories and understanding what they are without actually needing to read it. So again, we're going to use the same review and we're going to tell it to analyze the text corpus above and extract the key topics discussed. For each topic, provide a clear and concise topic title, a list of five most representative keywords for the topic, group related sentences and phrases from the corpus under the identified topic. Basically, we are giving it we want to extract different topics so that we can store them in the database, we can tag the articles or books with, and have a very structured processing language with it. Now, this is how we have it. We have the coffee quality, topic 1, service quality, ambience, overall experience, and it has a very good topics, extracted topics. Now, to build on top of that, we can also extract very specific information from a review or any piece of text. And this information can be utilized to do some checks or to save it in a database and process later, to know what to actually do with this text, and so on and so forth. So we can have a lot of use cases for that. So we can just write here information extraction. We want to information extraction. We want to extract information on a piece of text. So right now we have the same review, but we want to extract the product so that we can put the product in. We want to extract its sentiment, and it's also going to be in a JSON format. We want to extract the main likes and main dislikes. And right now, if you can see this, you can have 4 columns in a database and we can fill them with those. And this is going to be very important data for customer service people. And they can then quite read, they can then filter the product caramel latte, and then they can just see how many sentiments that are negative, see how many sentiments that are positive, and even can see why. So you can see here that it extracted the caramel latte with almond milk. Sentiment is going to be negative. And the main the main likes is the ambience, but the main dislikes was it was slow and the taste of the coffee was not good. So you can see that like this information extraction, like right now it can, like this is, you can imagine it as if it's in a row in a database, or like even triggering alarms based on the negative sentiment. So you can have different systems built on top of that. Now let's formally also introduce the thing that we did earlier, which is sentiment analysis. So basically, sentiment analysis takes in a review or whatever text and tries to classify it as positive, negative, or neutral. This is what sentiment analysis is, and it used to be a huge task in natural language processing, but with NLP and new chatbots, you can do it literally in one line. And yeah, this is it. We are using the approach to separate the output, separate the input, and then have a structured output. And then we don't have anything else except for an instruction to just have the JSON. Now, the problem isn't hard enough for us to use chain of thought. So right now, the output here is a JSON format, customer review. It also has a sentiment, and it is negative. Now, to expand upon this more, sentiment analysis is a type of classification, text classification. So what we can do here is that we can also formally tell you what text classification is and how we can also do it. So text classification takes any piece of text and determines whether this is like one class or another. So basically, you can have an article and you can tell it to classify it as this is either a sports article, a pop or a pop music article, or like is it talking about movies. You can tell it like to classify text based on that, so that maybe you want to have it tagged or you want to have targeted ads based on that. So there's a lot of use cases where you can just classify the text. And I can just give you a different example right here other than review. So right now, I want to classify whether something is an email, whether it's spam or not spam. And this is a model that Gmail has, this is a model that Yahoo has. And basically, it classifies things as spam or not spam and puts it into your spam folder. So for this example right here, I have an email, and it's basically the Nigerian prince email, which is a scam that is telling you to give it a very small amount of money, and in return it will give you like millions of dollars. It's obviously a spam and scam also. So you can see that we also have the email between XML tags, and we also generated this. We want to have the output as in JSON and the spam as in string that is one of those, spam or not spam. And if you can just run it, and it will tell you that this is spam is going to be spam. So yeah, spam and not spam. So this is how you can do text classification. Again, the things that we are covering right here are all NLP tasks that used to take a lot of time, but now in a lot of tasks, in a lot of scenarios, you can just use ChatGPT and not train your own models to have this sort of accuracy. And yeah, this is it. And right now, we covered a lot of NLP tasks, from like summarization to translation to sentiment analysis to text classification and NER. The last thing that we are going to be covering is how to build a chatbot that is specific to our use case, so that it can take orders, for example, like deal with customers, things like that. So the first step of that is going to have something called system prompts. So basically, system prompts define how the model is going to behave in a specific context. So instead of just writing the instructions right there in the prompt itself, you can just write it in the system prompt so that any other thing that comes into this conversation, it behaves to all of this conversation in a very similar way, and it has a very clear goal. So let's keep it simple and let's just do this classifier but with system prompts. So I can just write a system prompt right there. You are a sentiment classifier bot that classifies reviews into 3 categories: positive, negative, or neutral. You can generate the answer in a JSON format that has the following fields: sentiment, and always response in a JSON format. Now you can see that this is not the actual prompt. This is a system prompt, and it doesn't have the review yet, or it doesn't have the like the text to classify yet. So we can have the user comment like that. We can say that this product is awesome, and then we can have messages like this, and we can write that the messages is going to start off with the system message, and it's going to have the system prompt, and then it's going to have the prompt from the user, which is just the comment that is that came from the user. So like that. Now our functions right now only take in one prompt as the input. So let's go and define another function that takes in a list of messages instead of just one. So you can scroll back up like here, and this is the HuggingFace one. So you can just have a copy and paste it, and you can just write here response from, whoops, not here, actually in the second one, from messages, and it's going to be the HuggingFace one, so it's HF, and instead of just having the messages built right here, we can just take them and remove them from here. So this is it. This is the get response from messages. We can also have it for OpenAI, so you can just copy paste it and add it right here, add from messages like this, and it's OpenAI, and instead of building the messages right here, just take it as an input and remove it from here. This is how easy it is. So just copy this and go back down again, and now we are going to have the classifier, but only for the from the system prompts. So you can have the pipe and the output, and you can just print the output again, and you can see here that it classified the text correctly, and it put it into the JSON format, and those are both instructions in the system prompt. Now this will make our lives a lot easier, especially with our chatbots, because there is going to be ongoing conversation between the assistant, which is the chatbot, and the user. So defining a system prompt at the beginning is going to set the tone for the conversation. It's going to set the goals also for the conversation, and it's going to be a little bit easier and cleaner to have this implemented with system prompts. Now, before we go to having a full chatbot, let's also see how we can have a conversation with messages. So, conversational messages. Basically, a conversational message is just having messages that is going back and forth, that is also having the history of it. So basically, we can ask the model, what's the fastest animal in the world? It can respond like the falcon is the fastest animal, and then I can ask it, how much does it weigh? And it knows here that it is referring back to its conversation to the falcon, and it will get me the average weight of the falcon. So This is like a normal ChatGPT conversation, but we'll learn how to also put it here so that we can also like build a chatbot with it. So here the messages right now is going to have a user, what is the fastest animal in the world. Then I am going to run it. I think I have misspelled messages from when I defined the function, so let me go back up. Right there's an extra S right there, so I can just rename it correctly, messages right there. Make sure that I also spelled it right here correctly. Yeah, messages is correct. Then I can go back here and make sure that I have this correctly spelled, and this is now correctly spelled. And yeah, I can just run this again. You can see that the fastest animal in the world is the falcon, and it can continue on to measure its speed. Also, it mentions that the land animal is the cheetah, and basically sailfish or a blue tuna is going to be incredibly fast also, but it's on in the water. Now, right now, we just want to append this to the list of messages. Like that, and we say that append, which is going to give it the role, is going to be equal to the assistant, content is going to be equal to the output, and then we are going to have another message from me, from the user, that is going to tell it what's the average size. What's its average size? So it's basically referring back to the falcon, but it's not in the conversation. It's not in the same question. So it has to go refer back to what it is referring to. And right now we can just see the messages before we send them. We can see right now that the first message is what's the fastest animal, and it's from the user. The second one is from the assistant. The fastest animal is the falcon, and then it goes on. And then the third message is from the user again. What's its average size? That is the message's content. And you can go here and ask again for the response. Again, the average, it responded quite correctly, which is the average size of the falcon can carry depending on the subspecies of it and its sex, whatever. And you can see that it responded correctly, referring back to the messages that were sent back and forth. Right now, we have all the components that we need to start building the chatbot. We have the system prompt, we have how to separate inputs and how to structure them, and how to build messages on top of each other and have a conversation with the chatbot. So right now we can just have the chatbot part. Now, for the chatbot part, we are going to be building a customer service chatbot that is going to take an order for a small coffee shop that has like sandwiches and some things to drink as well. So the first thing that we are going to do is, of course, define a system prompt. So let's also here define a system prompt. So let's cover this system prompt. It's quite a big one, but it's a very interesting one, and you'll understand from here how you can make a chatbot specific to your use case with very simple like English. So you are an order chatbot, an automated service that collects orders for a sandwich shop. So I am now going to follow the specific set of instructions to have a specific output that I want. So the first thing is to greet the customers, and then I don't ask it to pick up or its delivery because it's going to be a chatbot, and And I am going to be also integrating into an app. So pickup or delivery right now, it's not going to be an option. You can exclude it, and you can also add it if you want. You can then wait to collect the entire order, then summarize it and check the final output, and finally collect the payment. So you can see here there is some steps right there that the chatbot should follow. Then it has the menu. So you can see that sandwiches, the turkey sandwich, ham sandwich, veggie, BLT, sides like French fries, and Coke, Sprite, and bottled water. So all this is the system prompt that is going to define how the chatbot behaves. So we can call basically the messages now as context, and right now is going to be have the system prompt is going to be equal to the system, and don't be confused, this is just the messages. So the accumulated messages like that. So we can have the output is going to be equal to get response from HuggingFace, and then give it the context, and then give it the output. So if you don't provide any user input, it should start off with greeting you. So hi there, welcome to the sandwich shop. What can I get for you today? So this is the output of it. So you can add to the context of it. So again, this is just the list of messages. And right now I am going to have the assistant. I am going to add the assistant's output to it. So this is the assistant output. I'm going to add it. Then I am going to add my own. So I am the user, and I'd like it small, please. So this is going to be I'm going to want it to be small. So I can just get this and just copy paste it, close this. So to confirm, you'd like a small turkey sandwich, correct? And then it's now confirming my order. So everything now is looking good, and for now, like the context is going to be all the list of messages. So for X, and we did not append the last message, so we can just append it right there. So for X in context, like this, and we can print X. So you can see right now that this is the system prompt, then the assistant, then the user liking to ask a sandwich, and then again. So this is basically a chatbot that is this is the back end of the chatbot. So every response is appended to the messages, and it's appended as an assistant, and the user is appended as the user. Now, this is fine and good, but we actually want to have an interface with Python. So we'll quickly do an interface right here and see how this goes. So for the GUI, we are going to have a pip install for the GUI. So we are going to use pip install Jupyter Bokeh. So you can just pip install it. And after it, it's going to ask you to restart the session. So you can just restart it. Just make sure, just take note that everything in memory is going to be filtered out. So you can just run it again, but you don't have to run the OpenAI stuff. You can just run this and make sure that your functions is already run. The other output things you don't have to run them if you don't want to. So you can go to HuggingFace, you can load the model, you can load the tokenizer, you can load the pipeline, and you can define those two functions again. Then you can go back here, back to the end, and you can just wait for it to finish while it's waiting to finish, then we can put the code for the GUI. So right now we are going to start defining the GUI. Right now, so we are going to import the panel, which is the GUI panel. It's going to have basically an input text for us, and it's going to have the output text from the assistant. So we are going to have the panels, which is the things that we are going to be displaying. And then the context is going to be the list of messages, which is going to be the system prompt, which is equal to the system. Again, if you didn't run the system prompt, run it after the restart so that it can be in memory. Then we can then tell it that this is going to be an input parameter. It's going to have a value of hi, a placeholder of enter here. Right now, this is just an initial value. It's going to be overwritten. So yeah, so over time, it's going to be overwritten by the things that I write. And then we are going to have a button that submits the chat. And then we are going to get the output from the model from this function that is called collect messages. Now let's define collect messages right there. Collect messages is going to take the input, and it's going to append the user to the user. It's going to take the prompt from the input, which is the input bar that I have. Then it's going to call the model, take the response, add it to the context, which is just the list of messages, and then add it to the things that we are displaying, which is the panels. So again, let's run this and make this clear. Again, this is the place that I write in it, which is going to be the input that I am getting the value of. This is it, INP, and those are the panels. And right now the user didn't send anything, and I went and asked the assistant to produce the output, which is this one. And yeah, you can just write here, I'd like a turkey sandwich. Press chat. Now you can see that it took this. It told me that it has 3 sizes. What size do you want? Then I can say I'd like to have the small size. So I'd like small, please. Like this. Like that. So you'd like to have a small turkey sandwich. Now you can see that it has it is overlapping, so you can just view output in the full screen and you can see it right there. Now to exit this, you can just press escape. Now the chatbot is working fine, and right now you know how to do specific chatbots for your use case that can deal with customers and can be a very important feature in your applications. Now, the last thing that we are going to cover is text clustering, which is clustering text into different parts or categories. And this might help to just like organize some text or put it into different sections, or like even having a specific task of filtering them based on a specific field or something. So text clustering is just grouping text together, grouping different documents together into different groups so that they can be referred to easily. So we can have a section here called text clustering, and this text clustering is going to be using the embeddings. So like we learned before, embeddings has a spatial, has a numerical representation of a text, and we can then do mathematical equations to group them together to see how far apart from each other they are and things like that. So the first step is to get a data set. Right now, we are going to have a very simple data set considering only 4 text samples, like this one, which is the first one is talking about the red panda, the second one is talking about iPhone 15, the third one is talking about dolphins, the fourth one is talking about Samsung Galaxy S3. Now, if you looked at this, basically, if you want to cluster those into two different clusters, but you can put the iPhones, put the iPhone and the Samsung into one cluster and the animals in another cluster. So imagine having thousands and thousands of documents and you want to cluster them together for one reason or another in the company. So you can utilize this. So this is a very simple data set that is going to help us visualize what we're doing. But yeah, again, things become very complicated in the real world scenarios, and you cannot just do it by eye. You need a system to automatically do it. So first we are going to do some embeddings. So first of all, we can have the OpenAI embeddings. Again, if you don't want OpenAI, you can skip it, and I will go to HuggingFace right afterwards. So response is equal to OpenAI client dot embeddings, like this, dot create, and in here I am going to give it the input as the text corpus of 0 and the model as the text embedding 3 small. And yeah, we can just run it and we can just have the output right there. And this is the embeddings. So maybe this is the first time you see actual embeddings, but you can see that it's a whole list of numbers and each number is representing a feature, and they are a lot. And this is going to be, I don't know how much OpenAI's features are, but we can see it together. So we can have response of data, response.data of 0 dot embeddings, like this, and you can see it's embedding. And you can see that this is a whole list of numbers, and to get the to know how much they are, we can just have a length of it. We can see the length of this embeddings. So those are 1,536 features. If you want to generate those embeddings for the whole data set, it's convenient for us to put it into a function. So let's put it embed text OpenAI and have the OpenAI client and then the text, and then we can have the response.embeddings.text3 small and then return back the output, and we can just generate the embeddings for the whole data set. Generate embeddings. We can just have a embeddings equal to the text on the text corpus, then embeddings.append. This is just an empty list. We are going to get the embed text and give it the OpenAI client and give it the text and have the whole list of embeddings. So this is now done. You can just refer it embeddings of 0, embeddings of 1, and it's working now fine. So this is how we can generate embeddings using OpenAI. But what about HuggingFace? So let's do this HuggingFace right now. So HuggingFace embeddings. Again, setting up HuggingFace is a little bit more complicated with a little bit more code. But after the setup, it's usually the same effort to use as the OpenAI one. So sometimes it's it's cheaper for you to put in the initial effort, and then you can just utilize it as if you're utilizing any other model. But you'll need resources, computational resources for that. Now, this is the function to get the embeddings for HuggingFace. And again, and right now we are enabling the hidden states. Again, the hidden states is the layers that is between the input and the output layer. And we are going to just need the final layer. So in order for us to embed text, we'll have to manually tokenize the data. So this is how you tokenize text. You give it the text, you give it the tokenizer, you give it the text right there, and you tell it to, if it has like more than the maximum allowed length, we can truncate it, we can pad it if it has like a very little length. Then this tokenizes the data, this returns in a list of numbers. Then we can just run those in the model like that. And then from the model to get the embeddings, like I said, embeddings is just the last layer of the hidden state. So I just get the last layer of it. And then I get the mean of the last hidden layer, and those are going to be my embeddings. And I am going to return them. This is going to be returned as a torch tensor. So you can put it into a CPU, and then because it's now in a GPU, and then you can just add it, make it into a list, so that now it's a list, and it's going to be the same as the embeddings output that we got from above. Again, we can just copy paste this, and we can utilize it just like we utilized the text embedding with HuggingFace. So right here, it's going to take in the text, the tokenizer, and the model. So model, I spelled it with 2 Ds, it just has 1 D. Now, this is going to be also a list of embeddings. Now, those numbers are going to be different than the numbers that are from above. Each model predicts different numbers. And here, you can also see that it might have different length. So, OpenAI had 1,500. This one has 372. So right now we can cluster text using an algorithm called k-means. And k-means is basically like this. It basically sees the data as points in a graph like that, or like different numerical points. And since the embeddings are also numbers, it can see how far away 2 points are from each other, and then it can assign each point a cluster. So right now we can assign it like there are going to be 2 clusters, and assign each of those 4 samples one of those clusters. So one of the ways that we can use this k-means, we can just have from sklearn.clusters import k-means. And means is misspelled, and import is also misspelled. And yeah, we can just import numpy also as np, and this is just an efficient array library in Python. It's cluster, not clusters, so sklearn.cluster. Then we can just get the embeddings and make them into a numpy array, because sklearn is expecting an numpy array. So we can just cast it into a numpy array, and if you looked at it, it's just the list of numbers, but in a different, more efficient format a little bit. We can then specify the number of clusters. Right there, it's 3, but we can just have here 2 number of clusters, and it's going to be equal to 2. Then we are going to specify that the k-means will have the number of clusters. We can specify a random state, and then we can just fit on top of these embeddings. So it will fit them and assign each cluster, each sample a cluster number. Now we can just present the clusters to us. So we can just have the cluster labels as k-means of cluster labels, and this will have the labels for each sample, like that. So it has 1, 0, 1, 0. Those are for each sample, its label. So what are we going to do is that we're going to just produce the text, the first 20 characters of the text, and then produce its label. So you can see it more clearly. So the red panda is going to be cluster 1. The dolphin is going to be also cluster 1. So those are categorized as in one cluster. And then the iPhone 15 and the Galaxy S5 and the Galaxy S3 is going to be also in another cluster. In this tutorial, you learned a lot about LLMs and how they train, and what is embeddings, temperature, weights, and more. And you took it a step further by getting hands-on experience with calling models from OpenAI and HuggingFace. And you also learned prompt engineering and practical NLP applications. Now, if you want to polish your skills by doing a beefy hands-on project that is going to boost your CV, then I have 2 free tutorials on my YouTube channel for NLP that I will link in the description. One of them is about creating a customer service chatbot for a coffee shop and deploying it on a smartphone application. And the other analyzes your favorite TV series with NLP, utilizing a lot of concepts and even building a chatbot to imitate your favorite character. Thanks a lot for watching and have a wonderful day.